Hello, my name is Jen. I work with the Micronaut and Micronaut Foundation team. We are pleased to have Sergio here with us today, Micronaut Product Development Lead at Object Computing and member of the Micronaut Foundation Board of Directors and our 2GM developer advocate. We also have special guests and Micronaut Foundation sponsors Marcus Kent and Florian Habermann from MicroStream. So welcome, guys. Thanks for joining us today.
Hi, everyone.
Thank you. Welcome.
Hi.
Awesome. So you guys are going to be talking to us a little bit about how to leverage MicroStream in our Micronaut applications, and we're really excited to have you. So we will be doing a live Q&A session at the end, so please stay tuned as long as you can. And we will have everyone muted, but we will try to get to everyone's questions at the end. So please go ahead and load those into the Q&A part of the Zoom application, and we'll try to keep track of those. And like I said, answer as many as we can. And thanks again for joining us. And I'm going to turn it over to Marcus.
Thank you, Jen. So try to share screen. You should now see my screen.
We can, yeah.
Yeah. Again, hello everybody, and good morning or good evening, wherever you are. My name is Marcus Kett. I'm CEO and co-founder of MicroStream. And yeah, MicroStream actually is ultra-fast in-memory data processing engine that allows you to process data in memory with pure Java. Together with Florian, our CTO, and our team, we are developing Java development environments and database tooling for more than 15 years now. And we started with working on a Java development environment, and we migrated everything to Eclipse and worked very long time on improving and accelerating the JBoss Hibernate tools for Eclipse. So we try to accelerate database programming, make it more simple for the Java community. All of these solutions are open source, and this is about our background. Currently, we're super proud to contribute now to the Micronaut project, and also MicroStream is open source. Yeah, MicroStream actually, what it is a Java native persistence layer that runs within your JVM, in the same JVM process of your application or microservice. And it enables you to store any object graph, any size and any complexity, or even individual subgraphs persistently into any storage, into any data storage. And vice versa, MicroStream allows you to load any subgraph. You can load the complete object graph or individual subgraphs on demand and restore it in memory at any time. And all loaded object references are automatically merged into your object graph. This is what MicroStream actually does. It's a tiny Java library you can download via Maven and include it very easily into your Micronaut application. The code is available on GitHub. It's under EPL, Eclipse public license, which means you can use it for commercial purpose as well. So as I mentioned, we are super proud to contribute to Micronaut, to be integrated with Micronaut, and to be sponsor of the Micronaut project. So MicroStream is not that new. So developing started almost 10 years ago, and first production use was in 2015 in a really mission critical project. And then some years later, we decided to build a company around the project. And last year we have open sourced it, and now it's MicroStream is super stable and production proofed. You can use it in mission critical projects. We are very active in the Java community and really passionate Java developers. And last but not least, we as a company provide some additional values to the open source project. So we're a main contributor. We provide a large test coverage for the MicroStream project and provide update warranty for enterprises. Okay, why in-memory data processing is pure Java? Yeah, well, as I mentioned, we have worked on traditional database development tools and frameworks for a long time. But in the end, traditional database systems, so this was our experience and the experience of our customers, traditional database systems are incompatible with Java from the technical perspective. And this leads to high complexity in software development. It leads to effortful development processes, expensive latencies through runtime, higher CPU consumption, higher memory consumption, higher CO2 emission, and in the end, higher costs of infrastructure. Why? So let's have a look on the architecture of a traditional database application. In Java, we use objects for almost everything because it's object-oriented, so everything is an object in Java. But as soon as we want to store data, we use relational databases. And relational databases are not able to store objects. They provide tables and relations. So we have an impedance mismatch here. And so the entire object model of Java is incompatible with the relational model. So we call this impedance mismatches. But the same thing is with NoSQL databases. So the modern NoSQL databases introduce a completely new data structure and formats. But no matter which database system you use, they are all also incompatible with Java object graphs. So we have a same impedance mess or similar impedance mismatches here as well. And in practice, to solve this problem, we need an object relational mapping, or for a NoSQL database, we need a data conversion, for instance, JSON conversion behind the scenes through every single read and write. And this is the reason why we have latencies through runtime, higher CPU consumption, expensive latencies, and so on. To speed up database queries in traditional architecture, we add a local cache. So we are used to do it. That's fine. And so we are able to accelerate database queries. But the problem is with distributed applications, we're going to have some problems here because let's say one of our nodes will change an object, store it into the database, then this node is in sync with the database, but all of the other nodes are not in sync with the database. This might be a problem of consistency. So what we can do now is we put a cache in between of our application and the database. And to avoid a single point of failure, of course, we are used to run a cache cluster. So we need additional machines in our system and additional complexity. So, and if the load increases, then we are used also to use a database cluster. So we have 3 layers, we have 3 clusters, lots of machines, lot of CPU power and consumption, and high costs of infrastructure. And we believe with in-memory data processing, we can improve this. Why in-memory data processing? Well, here are some interesting numbers every developer should know. So this is from GitHub. Here you can see access to memory can be up to 1000x faster in comparison to reading data from a disk. And most of the traditional database systems, they are access to disk through every single read. When we don't read the data from the cache. So in Java is really made for in-memory data processing because of our JVM's JIT compilation system. So it provides max performance for everything we do in the memory. With GraalVM, now we are even able to create native images, so to accelerate our startup time. So that's great. Everything Java provides is really made for in-memory computing and high speed. And Java also provides a perfect data structure. We have an object graph from the beginning. So in an object graph, you can do everything. You can use all Java types. You can use collection. So it is a multi-model data structure. And so this is the perfect data structure we can use for almost everything, to store single objects, to store a list, or really high complexity with circular references. And Java provides the perfect query language. So with Java streams, you're able to search and filter an object graph. It's a great API. It's type safe. It's easy to use, and searching really even huge object graphs with gigabytes of memory up to terabyte in memory, it mostly takes only microseconds. So when we talk about database query time, then we talk about millisecond query time. And when we talk about searching object graphs with pure Java, with Streams API, we talk about microseconds, up to 1000x faster. So the only thing missing was actually a native persistence for storing object graphs seamlessly. And this is actually what MicroStream does. This is not our invention. So there is a concept called system prevalence. And with system prevalence, this is the simplest way of getting persistence of your POJOs. So you keep the system state in memory, which means you keep your object, your data in memory. And anytime your object changes, you serialize it on disk. So this is a simple pattern. The architecture is super simple, and everything that's executed in memory is fast. This is the concept that MicroStream follows. So let's have a look on the architecture, what we have done with MicroStream. So we have, again, let's look into our database, because mostly it's a black box. We send an SQL, but nobody thinks about what does the database internally. So we have also a data storage, of course, where database writes data on disk, mostly in binary formats, sometimes JSON or XML. Then we have a database management system. The database loads data into its own memory, tries to keep data and caching in memory. And then we have some business logic, stored procedures, stored functions. Then let's have a look on our Java architecture. As I mentioned, we have an application or a microservice. We keep a data in memory, our data objects, and we have object relation mapping or data conversion, and a local cache running on the JVM. So we replace object relational mapping or data conversion with MicroStream. Next, our in-memory, our object graph in memory now becomes our in-memory database, which means everything is in memory already. We don't need a local cache anymore. Then, because of our object graph becomes an in-memory database, we don't need a database on a remote server anymore. So we can skip it. The only thing we keep are the persistent data in our storage. And then we got a really simple, clear architecture, fully object-oriented concept. We not store the entire system state, so we only store the changes. So to become a high efficient, persistent and a high-speed persistent. In terms of the storage, you can really choose almost any storage target. So we have, you can use plain files, of course, but we also have connectors to all important database systems because we store binaries. So MicroStream serialized the data on disk, and we have introduced a binary format for that. And MicroStream runs wherever Java runs. You can run it in a container, in the cloud. It runs with Java native, with GraalVM native images as well. And it even runs on Android. The only requirement is Java version 8. So MicroStream bases on a completely new written serialization that is around 10x faster than Java serialization. It's based on a byte format that allows us to deal with even very complex object graph with circular references. So it can do whatever you like and model everything you like. We have this persistence layer for the JVM, persistence layer for Android. We added so-called legacy type mapping that handles your class changes. So when you change classes, MicroStream can handle this automatically. And you can also add a legacy type mapping for more complex cases. Then we have a file system garbage collector because all persisted data are stored, appended on disk. So each store is a new binary in your storage. And when you class changes, then MicroStream removes the older versions of your objects from the storage automatically through runtime. You also have a file system abstraction, which means your storage can be everywhere. It can be in S3, on a local storage, in a database system in the cloud, so everywhere. We have database connectors, a REST interface that allows you access to the storage data, and on top of that, we provide a user interface where you can browse through your storage data. Native backup functions. So if you use a database system, you can use the backup functions of the database system, but MicroStream provides you also backup functions. We have also converter for CSV, and other converters are work in progress, like a converter for protocol buffer. And the newest thing is now a MicroStream cluster. And this altogether is MicroStream, the MicroStream persistence engine that is completely open source. Okay, let's have a look on the performance. So this is a performance demo. It's a simple bookstore demo. The code is published on GitHub, so you can check it out, try it out, implement your own queries, play around. Here we use two applications running in parallel. One is built with Hibernate and cache. We have 250 gigabyte of data, and here we use a PostgreSQL database. The other application is built with MicroStream as a persistence layer. Here you can see the query code, and each query is executed much faster with MicroStream. This is actually not correct because this is not MicroStream power and speed. This is actually JVM pure Java speed, because we search the object graph in memory, streams API. This is core Java, and here we can see, yeah, each query is sometimes 10x, sometimes 200x, 200x, and sometimes more than 1,000 times faster than a comparable JPA query. With MicroStream as a core framework, you can use it for single JVM applications. But with the new MicroStream cluster, you can now also build distributed applications. And our new MicroStream cluster bases on Micronaut. So you get a complete Micronaut application, and actually you got a complete Micronaut application cluster. So here is our traditional cluster architecture. With the MicroStream cluster running on Micronaut, you can now replace your application nodes with Micronaut application nodes or microservices, of course. Then mostly you will need only, let's say, if you have 10 or 20 application nodes, traditional nodes, then perhaps you will only need 2 or 3 Micronaut instances to provide the same performance and power than before. So you will save lots of CPU power. And because we only need a binary persistence, we don't need a database cluster anymore. So it's not mandatory anymore. If you want to distribute your storage data as well, you can use Amazon S3, for instance. So we save lots of machines, and because of our object graph in memories, our in-memory database, we replicate the object graph through even hundreds of JVM machines. We don't need a distributed cache anymore. So we can remove the complete caching layer. Now we get a super simple, pure Java architecture and save tons of CPUs and costs of infrastructure. Here in comparison again, traditional cluster in comparison to a Micronaut MicroStream cluster provides you extreme performance, real-time applications, and you save lots of costs and infrastructure in the cloud. The MicroStream cluster will be available in the cloud. So we provide a Micronaut MicroStream cloud and also for on-premise. So the benefits, I guess, are clear. Ultra high performance, lower cloud resources required, and customers really save up to 90% cost of infrastructure. And it's super easy to implement because there are no more database-specific data structure, no more client APIs, no more query languages you have to learn. Everything is core Java, and it's open source. And here for an example for one of our clients, Alliance in Munich, for instance, they save up to 90% costs in the cloud on AWS. Of course, there are also challenges with MicroStream because this is built for Java developers only. So if you're a Python developer, I'm sorry, you're out. And it's also a paradigm shift in database programming because we are used to use a database server that runs on a remote machine, and we send a query to a remote machine. This is different with MicroStream. So now the data are in memory. Our object graph in memory is our in-memory database. And we have to care for something because we have no database management system anymore. So we have to care for concurrency, but core Java, again, provides us everything we need. We have to care for validation and for locking, but mostly in database programming, we do it anyway. So this is built on separation of concerns. Java provides everything we need. We can implement everything in Java, and MicroStream only cares for storing your data and restoring your object graph. It's not suited for DBAs, so if you're administrator, I'm sorry, then you're out. So it's really developed for Java developers, and we try to get out the most of Java. We have this paradigm shift from a remote database server. Here on the right side, we can see the database now is in memory. Keep this in mind. Your object graph in memory is your database. But don't be afraid of memory, because If you don't have enough memory, this is not a problem because we have lazy loading. So you can load only single subgraphs when they are needed on demand. So it depends on your use case. If you build microservices, for instance, then you want to have, you deal with micro machines. You have not much memory power. So you will keep everything with lazy loading, load only some data you need initially, everything else use lazy loading. Then you can have also a terabyte in your storage target and run it with only 1 GB memory. This is really possible. If you have enough memory, then you can use it, of course. So we save lots of infrastructure costs. You can invest in bigger memory machines. So it depends on the use case. If you like to learn more about MicroStream, you can check it out, download it free, play around. Yeah. And Florian, do you like to show some code for?
Yeah, sure.
I guess we don't have enough time. I'm sorry. So we only have 25 minutes. Perhaps we can, after Sergio, your presentation, we can show some code, some simple code in our examples.
Yeah, sounds fine. Let me share my screen and show the MicroStream integration. I think you have to stop sharing your screen, exactly. Share my screen. So, hi everyone. I'm Sergio Del Amo. I am Micro Developer Lead at Object Computing. First of all, thanks to all the sponsors and thanks MicroStream for sponsoring the Micronaut Foundation. Micronaut is a modularized framework. So if you go to docs.micronaut.io, you will see that we have many modules, and the MicroStream module is under data access. And you can find what we typically refer to as the reference documentation if you click there. Another resource that we have if you want to learn more after this presentation, if you go to guides.micronaut.io and you search for MicroStream, you will find a guide as well. In Micronaut is build agnostic. We support Maven, Gradle. Micronaut is a programming language agnostic. We support Kotlin, Groovy, or Java. You can write, you can leverage MicroStream with any of those programming languages in a Micronaut application. That's not an issue. And in fact, the guide, which is a step-by-step tutorial, basically is written in the programming language that you prefer. So if you want Maven and Kotlin, you will find here the Kotlin code to use. All of our guides, they have like a zip file which you can download with the complete solution. So that should be there at your disposal. I'm going to show you with a demo the biggest features that we have for MicroStream. I have here, this is actually in a public repo. So I have this to-do application under Del Amo micronaut2do.com. So I will paste a link in the chat. So if you clone that repo, you will see a project such as this one. And here I am showing different runtimes with different persistence. And this is, I think, a good opportunity to compare how simpler it is to build a persistent layer with MicroStream in comparison with something such as Dynamo. So if you check, this is a multi-project built in Gradle, and it has a repositories MicroStream, a repositories data JDBC if you want to use microdata, or a repositories DynamoDB. So if you see, this is the code for DynamoDB, and this is the code for MicroStream, which is just a couple of classes. And now we'll show you in a second what they are. When you work in a Micronaut application, with MicroStream, you will have a couple of things. First, you will have the MicroStream dependency, which has a transitive dependency to the MicroStream dependency that Marcus mentioned in his presentation. So this is the only dependency that you need. And you also need like a dependency on an annotation processor dependency to MicroStream's annotations, because we have a couple of annotations which will make your life easier when working with MicroStream. So with the dependencies in place, the next thing that you will have to do is in configuration, you have to tell which is the root class of your MicroStream instance object graph. This is important. We support multiple ones. So if you, for whatever reason, you had like one part of your application has like a MicroStream persistent instance for, I don't know, like your customer support and another one for your other application logic, you could have multiple. So in my demo here, I only have one. We use like the name qualifier. So this is to-dos. This could be anything. This could be foobar. And you could have another one here called to-dos with a different object graph. So this is, we support multiple MicroStream instances in your Micronaut application. So once you have, let me actually make the font bigger, sorry. Bigger. So just to recap, so you need the dependency in place. Then you tell us which is your root class. And the way you do that is via configuration. So this is my root object. So if you, let me show you what we are trying to implement. So this application is a to-do application. I will show you running in a second. So it has like a repository similar to what you may have in other Java applications. And this is something similar related to what Marcus said. So Micronaut has supports a subset of the beam validation specification. So you can ensure that the data is valid through your system using like a standard Java validation. So validation is built into the framework, and I saw it in all my demos because we believe that that's a good thing for you to have in your application, and that plays perfectly with MicroStream. So I have here my interface, and what I'm going to do is I'm going to implement this in with MicroStream. And as you see, this is like a save, delete, find all, find by ID. To do is a project which has a unique identifier and a task. So this is like kind of what you will probably have in your application. So something that we uniquely identify so that we can have like a unique URL and some data about it. And then we have another class, which is, we have another interface for saving, for example, WebSocket connections. And WebSocket, again, is another Java object with some private finals, a constructor, getters and setters, sequence and hash code, what we are all used to in Java applications. And the way I have organized this in MicroStream is I have this root class where I have like a map of this, the key of these maps of to do will be the user unique identifier. And then per each user, I have another map which maps to-dos. So each to-do, as I told you, has like a unique identifier. So I have chosen to organize my map this way. And then in my to-do repository, the only important thing to remember, and this is what Marcus was mentioning about, this is a bit of a paradigm shift. You just have to think about this rule, which is honestly 2 sentences, is the rule is the object that has been modified has to be stored, and to store a newly created object, store the owner of the object. With that in place, for the save, when I don't have like for a user who doesn't have any to do, I have to store the owner of the object, and for the other one as well. So I created 2 methods, one is save, one is append. And what I use here is 2 annotations in Micronaut. One is call store returns, another one is call store params, and those annotations will make your life easier when working with Micronaut and MicroStream. Micronaut, when you are running, for example, Netty, is you are expected to have like a multi-threaded environment. And because of that, what these annotations will do is they will execute this code synchronized. So they will do that for you. So essentially what we are saying here is, for example, when I am deleting a to-do, I am deleting a to-do the way you will do in Java. So I am essentially removing the entry from the map. And I am returning the user's to-do and storing that. And when I am saving a to-do here, what I am saying is, because store params, I am essentially saving that parameter. So you just have to think about this rule, and you can leverage the Micronaut annotation, and you are good to go. So this application, indeed, I am not like going any more low level. If you need to go more low level, you have all the MicroStream API at your disposal. And what I mean is you can dependency inject into your classes the storage manager if you need it. So if you check our reference documentation, you will see that we have an example using the storage manager directly. And you see here that we have to like do the synchronization here manually. And you have the same example, but using just the Micronaut MicroStream annotations, which will, I think that I recommend for you to use those, because they will make your life much easier. So those three things in place, dependency, configuration pointing to the root class, and a class saving. The other thing that Marcus was saying in his talk, and I think this is really important. So you see that when you are like persisting something or modifying the data, you have like to use the annotations. But when you are querying, you don't have to do anything. You are just using here Java, the way we query with Java. So you can use either the Stream API, or here I am just like getting data from a map. So nothing, you don't have like to write any SQL query. This is just pure Java as you are used to. So as you see, extremely easy to write persistence with Micronaut and MicroStream. And what I'm going to do is I'm going to actually go here, and I have here in configuration, if you want to write this in disk locally in my computer, I have this application dev. So I am running this is like my development environment, and I am saving this in a folder called Micronaut to do. So let me remove that folder. Let me show you the application running. So if I go to my root folder, and I probably have like a Micronaut to do folder here running. So let me just remove that. And let me just run the application. So I'm going to just run it with app. So if anyone is curious, I actually wrote instructions in the README file about how to write this with MicroStream. So if you just run this command, as you see, I don't have even Docker running in my computer, which is strange nowadays, but that's kind of the beauty of working with MicroStream. You are just working with Java. So I don't have like to start a database to start working in this application. So I'm going to just run the app. Stop the other app, which was running before. And I will tell you more about the warning in a second. So I have a to-do application here locally. This application is, when running in development mode, I am hard coding a user, but this application has server-side render HTML with a Thymeleaf. It has Micronaut security. It's using also Hotwire Turbo with a WebSocket server. So if I open here another browser here, so I open in the left side, I have Safari, and on the right side, I'm going to open Firefox. If I do here, learn about MicroStream, and I click save, via the WebSocket connection, I got an update in the other window. So this is, of course, it's a simple application. It's just a plain to-do application, but I think hopefully it shows that it's using several of the models of Micronaut. So we are using, it has a REST API. It has server-side HTML, security, validation, dependency injection, so all the good things that you can expect from modern application development. and it's all persisted with MicroStream. So when I persisted here the applications, if I go here now to my local root folder and I do here micro-todo.com, you see that it wrote to my disk. So if I now stop the app and I go to my browser and refresh it, and I start the app again, the data should still be there, right? So it's not just in memory, but MicroStream took care of persistent to disk so that the data is still alive upon application restart, right? So what do you expect? So when working with MicroStream, one of the things that you are going to see, especially initially when changing the way that you work, is you may want to check if the data is actually being persisted as you expect. And one nice thing that MicroStream provides is they ship with a client graphical user interface. So if you go to the MicroStream documentation, they offer this jar file which you can run, and it will display like a graphical user interface. So I have downloaded this jar file to my computer. I have it actually, just kill this. So I have it here. Let me just move the Zoom window. So I have it here. I have this jar file here, right, that I downloaded. So what I'm going to do is I'm going to execute it. So I'm going to do MicroStream. I'm going to execute it, and I pass the server port 888. This is going to start in port 888. Let me just get it out of the way here. And if I go now to port 888, it tells me to connect to an instance, right? So in order to connect to an instance, you will have to have an instance of the MicroStream REST API running, and the graphical user interface will consume it and give you like a graphical representation of the data. So what we did is we have an additional dependency, which I have here as a development-only dependency, which is called Micronaut MicroStream REST. And what this does, it exposes an endpoint called under /MicroStream, where the MicroStream REST API that the MicroStream graphical user interface expects is exposed. And in fact, if you have multiple MicroStream instances, as I told you before, we will expose like different endpoints. And what I did is, if you check my application, because we are using MicroStream security, what I did is that this is anonymous. So what we recommend you is that you don't have your applications in production with the REST API exposed, otherwise you will be exposing all your data. That's why I have it here as a development-only dependency. And that's why when we actually run the application, you will see like this warning here being printed, like it's telling like that you are like running MicroStream REST, but this is like only for development. And indeed, you have to also enable it. So it's not that you have to have the dependency, but you have to enable it. So we have gone a little bit the extra mile to ensure that you don't accidentally expose the MicroStream REST API if you don't want to. So with all that said, I have here my to-do application, right? And I started here, so I can say I'm going to connect to localhost instead of this port. I'm going to connect to the port in my Micronaut application. By default, Micronaut applications will start in port 8080. So I'm going to connect to localhost 8080 MicroStream. Now I click connect, and this is going to give me like a visual representation of the things that have been persisted. And you see here like my hash map of the users to-dos, and inside you see here like the to-do. So you can see like the thing, and you see like the unique identifier of the to-do and the content of the to-do. So this is a really nice add-on that we have in Micronaut for working with MicroStream, is that it's really easy to connect the MicroStream graphical user interface client to see your data. Another thing that we have in place is if you are using Micronaut management, which is allows you to expose a health endpoint. If you come from the Spring Boot background, this is similar to Spring Boot actuators. Once you have this dependency in place and you are using MicroStream, so what I have done here is I have also set that the details of the health endpoint are exposed. I have actually put this only in application dev just to show you. So if I come here and I do a car localhost 8080 health, and I do a pipe to JQ to get like a more visual representation, hopefully, probably not because it's blue with a blue background, but you will see here like the detail. And again, this supports also like having multiple MicroStream instances. So it's telling me that. So what I am trying to say is that MicroStream provides a health indicator that is used in the health endpoint. So the health endpoint by default will have like a disk space check, a discovery client, and if you have MicroStream, it will provide you also like a health check. The last thing that I wanted to tell you before we do like a Q&A, maybe Florian has time if there are no questions for showing some extra code, is MicroStream. You can use MicroStream for persistence, but we have also, in Micronaut, we have a cache module. So you can use MicroStream for persistence, but also for cache or for both if you want. So we have support in the cache module for things such as Hazel cache, things in span, but also for MicroStream. And we have like the instructions here as well. So it will be like just another dependency you can configure like cache. And the nice thing about using MicroStream with cache is that the cache will be still alive upon application restart, because so it's similar to if like you are using like in-memory cache, but with the benefit of MicroStream, which is that it persists. So this is like another option for you to try MicroStream in your Micronaut applications, is to use our cache integration, and that's possible because MicroStream is JSR 170 compliant, so that will be possible as well. And yeah, I think I covered everything I wanted to cover. I don't know if there are any questions. Yeah, one last thing that I wanted to mention is the easiest way to generate a Micronaut application which uses MicroStream is if you go to launch.micronaut.io and you select here MicroStream. You can select either the cache that I was just telling you, or MicroStream and REST. So I can say, give me MicroStream and MicroStream REST, and it will automatically add you so if you are a Maven user, it will add you the necessary dependencies in the pop.xml. So I have here my MicroStream annotations, my MicroStream as compile, all the dependencies. So everything that you need in place, and I don't think we generate any configuration. We don't generate any configuration. So that's everything I had on my side. Let me check the Q&A. Will this presentation be available on the website? I would like to show it to my software director. I think that's probably a question for Jen, but
Hi, Brandon. Yes, so we'll make sure that everyone who signed up for the webinar will get a recording of it, so you can pass it along to whomever. And we do have a little bit of time left. I know a few Q&A questions are coming through, and we'll get to those. And then any time left that we have, we will try to get Florian up here so he can show as much code. And I do know that right before this, Sergio was just talking about having the guys back on a podcast. So anything that we were not able to cover, hopefully the guys can get to it in a follow-up podcast as well. So stay tuned for that. And if anybody has to drop off, thanks again for joining us. But if you can stay for just a little bit longer, we will try to get to as many of the questions and to Florian as well. So, and we do have a question from Rob. And it can sit, oh, Marcus, are you going to answer that? Okay. Yeah, awesome. And then it looks like any considerations to note when using MicroStream in Kubernetes. Does it need a persistent volume for the persistent store?
Basically, you can use everything which takes bytes in some form. Persistent volume is one of it. But you can connect to cloud storages as well, like S3 or the Google Cloud storage, wherever you're running it. But you need to have a service or hardware of some sort to get your bytes written to, and that's not a thing of Kubernetes, but on wherever you're running with MicroStream. You just need a system which takes byte in some form. Yeah.
Okay, thank you. All right. So for right now, that is all the questions. So Florian, if you want to go ahead and show whatever you have, and then if any more questions pop up, we can get to those. But please go ahead and show what you wanted to show so folks can see that.
Yeah, sure. So basically, Sergio told the most of it already. If you want to use MicroStream, it's a very simple approach. So if you're designing your object model, you don't have to you just write your poachers with plain Java. As you can see, there are no annotations, no implements serializable, no extends some special superclass. Just take your poachers as they are or third-party types, and MicroStream will handle them fine. For most of these types, MicroStream will generate generic type handlers to enable our serializer to work with them, to convert them to bytes and back to get the persistent state. But if you have special needs for special cases where you want to tune the performance a little, or where to tweak some stuff, you can write custom type handlers and inject the type handlers at the startup phase in MicroStream. So that's your object model. Just write your code, use collections, whatever you like, and MicroStream can persist it and restore it. In the starting point is the embedded storage manager type, which connects your object graph via a route to the persistent layer. And that's what it's done here. First of all, it's a little configuration stuff, storage directory or the channel count, which is basically a thread or IO channel parallelization. And the storage manager has a root. And this is the entry point of the persistent object graph or persistent subgraph of your application. And here we see if no root is present, some random data will be generated and you're good to go, and the application starts up fine. If a root is present, all eagerly loaded stuff will be loaded into memory automatically. You don't have to worry about querying anything at any time at your application. The only thing, if you're using lazy loading, you have to call a simple getter function of the lazy type, which can be used basically anywhere. For example, if you look at our purchases, we have different collections, and at this point we want to do lazy loading. All the values of the map should be lazily loaded. And that's one of the reasons why we use a type, an actual type for lazy loading and not an annotation. Because at this point you cannot write annotations. So if you would use annotations, you only can write annotations on top of a field or a parameter, but not inside a generic parameterization. And on the other hand, we have to didn't want to use some kind of magic class file manipulation in the background, and therefore we decided to use a type and not an annotation. So your classes stay the same at runtime as you expect, and it's easier to debug anyway, and less error prone. So that's the only thing you have to inject into your business model, one simple type for lazy loading, and that's about it. And then you can decide when to load data lazily, when to unload it. And that's how you can ensure your memory doesn't run out. But you don't have to take care of all the lazy references by yourself. It's done by a lazy reference manager in the background, which will clear up the least used lazy references, basically your cold data, and keep the hot data in memory. And the manager will be started automatically with the embedded storage manager with a default configuration. If you want to tweak it, you're free to do so, with basically like any other aspect of the MicroStream engine. It's a purely interface-based design, so you can exchange, re-implement anything you want and adjust it to your needs. So that's everything you have to do to load data. Connect to an embedded storage manager, to an object graph, call a simple getter of the lazy, and every other parts of your graph are loaded automatically. And now we can take a look how complicated it is to store data. The Micronaut guys did it with annotations, and you just say, hey, I want to store the return value or the parameter, and what's happening in the background is basically a method call. Let's have a look at maybe the customers. So we want to add a customer, and we hand over a persister, which is an interface implemented by the embedded storage manager. For example, we add the customer to our customer map, and the only thing we have to do is call one single store method of the embedded storage manager, and that's it. This store call is an implicit transaction. You can open a transaction by yourself if you want and store multiple objects at the time, or you can call the store all method of the storage manager and hand over multiple objects which are put in a single transaction. So, and that's basically all the API you will need 99% of the time. A simple getter, a simple storer, and that's it. And for customization, you can re-implement basically everything, like I said, and write on type handlers, on memory managers, and whatnot. Best is to have a look at the documentation, and the GitHub page, in my eyes, is the best starting point. You have links to everything you need, the reference manual, the examples in our repo, and the demo, which is a simple graphical application as well. It comes with a simple user interface. I have it running locally here, and if you open the page, you can use a simple user interface and browse through the code of the demo. It's a fully fledged application which has multiple aspects. It's application with a user interface. We connected a UI. We connected a index with where is it? I have to check it. With Apache Lucene, of course. So you can use full text search inside your object graph, for example, because Java doesn't offer a lot of full text search capabilities by default. So you can just connect Lucene parallel to MicroStream, and we have a GraphQL endpoints exposed. So as an alternative to REST, if you like, just to have a look what's possible, how to expose your data to the outside. The most common way, of course, will be REST, as Micronaut offers by default. So that's just an alternative, how to expose or communicate with external application. And that's the best starting point, where you can see how to design a application with MicroStream from ground up. because it's a bit of a different approach, since your application becomes the source of truth and not your database, and you don't have to think in flat tables anymore, but you can design your object graph dedicated to solve your real-time problems and not to solve technical database problems. All right, so the questions: how would be a good architecture when using auto-scaling loading balancer to scale a large loads? Though I think that's a question for you, Sergio. Is it, Francesco, do you mean how to scale load large sets of data, or how to design a Micronaut architecture?
So typical, I think the question from Francisco is, in a traditional application such as what Marcus was describing in the beginning, you will probably have like a load balancer, and then you will have like several instances of your application connected to a database. In a MicroStream Micronaut application, you probably won't need like you will probably have like a big instance, and you will not connect to any database. So the only thing that instance will probably have more memory than your typical instances that you will have when working in a traditional application. And if your application has really enough load that you need to have multiple parallel instances, that's where the MicroStream cluster will come into place. But typically, what you will see is that you will not need to have like a lot of machines behind the load balancer, but you will have probably like a single machine with a lot of memory. But to talk more about the cluster, probably Marcus can give a better answer than myself.
Yes. So this is really the idea behind also to scale up and scale down tiny microservices. So if you want to build distributed microservices, then but you also can run big memory machines. So both approaches are possible with the cluster, and the architecture is actually pretty much the same. That's a great thing. So you don't have to think about how you design your application when you want to run distributed applications or microservices, and how you want to scale it. So it's pretty much the same code. The MicroStream cluster does the work for you. So we provide object graph replication, and everything is done by the cluster. So every store you execute, every store is distributed through all of your machines, and the cluster cares for load balancing. Of course, if you build your cluster for your own, then you have to build the infrastructure for your own. So we will provide a documentation for that. If you don't want to do that because we want to focus on writing business logic and focusing on building the application logic, then the simplest thing is to use our cloud service. Then you can create, you can define your cluster by only some mouse clicks. You can use auto scaling. Then you get from out of the box, you get a Micronaut cluster. So everything is based on Micronaut. So you can deploy your Micronaut application or service into the cloud. And then you can define how many nodes you want to run, and how auto scaling should work. So you can define that the cluster will scale from 80% load or 60%. So it depends on your use case. And then you can define a max and a max amount of machines. and then your cluster will scale automatically out and will scale automatically in when the load goes down. This is super flexible and saves lots of money. So everything will be provided by MicroStream Cloud, and you also can run it on-prem. But there are no specific requirements to write your application code. That's the great thing. So you can start using MicroStream running on a one JVM machine, and then if it's necessary to build a distributed application, highly scalable, then you can run the cluster.
There is another question also for you, maybe for Florian, is does MicroStream do any compressions for object types? For example, with protobuf under the hood, or is everything just stored as is? What if you have time series of data of type double or float? Does MicroStream scale well to arbitrary binary precision?
So MicroStream doesn't do any compression under the hood by default. If you want to tune the binary expression or the binary form of your object, you can do it with custom type handlers, and so you can save a lot of memory or a lot of disk space, of course. If you have maybe time series or machine data where you have millions or even billions of records, when you tweak the binary form, you can save a lot of memory with that. And the binary precision is the same as with Java, depending on the types which you are using. Of course, if you use double or float or the big decimal types, you get the binary precision of the Java type. MicroStream doesn't change the stuff like there, and you don't have loss of data like with JSON or JavaScript in some cases. MicroStream will restore the values as they are in memory.
This is also the reason why we decided to use a binary format. So then everything can be built with pure Java. You can use all of your types. You can use inheritance, circular references, and also the depth of your object graph is not limited. So you can build whatever you like, and MicroStream will be able to store it seamlessly.
Awesome. All right. Well, I think that is the end of the questions that have come through. If anyone has any additional questions, I think everyone has my contact information, so please feel free to email me. I will make sure that the guys get those and we can get those questions answered for you. I did put a link in the chat for the upcoming training and events that we have. And like I said, please stay tuned for a follow-up podcast with the guys, and we'll continue this exciting discussion. So thanks again, and thanks guys for joining us. We really enjoyed this informative webinar, and we look forward to speaking with you all again. Bye, everyone.
Thank you, everyone.
Thanks for having us.
Bye-bye.